Hello everyone. In this video, I'm going to show you how can we apply the support on a beam, and also how can we apply the load. So to apply the support, I, I do not use a specific plate or some type of cylindrical, semi-cylindrical shape on my beam, because, for example, if I want to apply a cylindrical, like half cylinder surface or half cylinder solid, or a rectangular solid plate here, then I'll have to define contact between my beam and also and the support. And contact is not good for convergence of lot of analysis models. So to simply use the support and get the support reaction, what we can do is we can select the area where our support is going to be. In the previous video, I created this area using the partition face option. So we can just use these surfaces and couple these surfaces to a single point and apply the support reaction to those points. So these two area, the right and left area, are for my left, right and left support. Let's create an area where I want to apply the load to. Remember, if you are testing a real beam, you cannot apply a load on one point. It's either going to be a load, like if you are applying a load with a roller, it will be a line load, or you will have a steel plate of definite size. So you are applying the load over an area. So that's why we use an area instead of a line for the support reaction and also for applying load. Let me create a uh, area to apply the uh, mid-span displacement loading. So my loading area will be also 2-inch wide by the depth width of the beam. So let's create parallel face. So I want to select, say, right face here. That's my surface. I want to enter value, flip direction of the arrow, and my first, so my beam is 3000 millimeter long. So if I want 2-inch wide, that means 50 millimeter wide support area. So the first datum plane needs to be at 1450 millimeter, and the next one needs to be at 1550 millimeter. Sorry, I think I made a mistake. Let's apply the area load over a 4-inch wide area. So I don't want to go back again. So the next datum plane should be at 1550 millimeter from this surface, and place enter. And okay, so we have datum plane now. Let's partition this face. So click to this option and use the partition face, use datum plane option. So select this surface, and now it's asking select. So click on done. Now it's asking select a datum plane. So I want to make a partition at this location. It has created one. Now I need to create partition on this face. Done. Select the other face here. Done. I also want to select a middle plane. I think we can do it later. So as I said, we can apply the load over this whole area. That's fine. But if we want to collect the support reaction from this area, easy way we can do is we can collect all this surface area to a single point. This mechanism is called coupling in ABAQUS. So whatever happens to this whole area, you can collect the information from that single element, single point. So I want to create reference point and couple this area to that point, so that whenever I apply the support reaction, support constraints, I apply to that point only, not over this whole area. And also after analysis, when I want to get the support reaction forces, reaction moments, for example, then I can collect it from this single point. I don't need to collect it from this whole area. So to do that, I will have to have another point here. Let's create a middle point. So I want to partition this space again using these 2 points. Okay. So now let's select this space, done, and select a starting point. So now you can see, since we selected the 2-point option, between 2 points, it's showing the midpoints and the corner points. So I want to create a partition by these 2 lines. So you can see it has connected this with the shortest distance between them. Let's do the same thing on the right support, left support too. I need to partition this one. I want a partition along this line. Let's do the same thing on the loaded area as well. So support, select this surface, starting point. I can see the yellow point. I don't know if you will be able to see it, but you can see the midpoints of this line and this line. So by selecting that, we can do it. We could have created a parallel plane like this, parallel datum plane too, like the previous ones. But since it will have these planes visible, so since we have the 2-point option, that's been better. So now let's go to interaction and create reference point. Okay, so create a reference point. I want to create my first reference point on the left support. So let's select the middle point here. I think from a previous model, I have the reference point already. But what I want to do is, it's asking select a point to act as a reference point. So it will show these middle points, as you can see. I will just show you something else too. So if you click on this option, create display group, remove your part model instances. So say I will remove some of my parts, then I can work on uh, oh, oh, sorry, I have some other parts here, so that's why it was showing like that. Let me go back and do it again. So now let me create 3 reference points, two for support reaction, one for loading. Now let's go to interaction module, reference point. So select this middle part, that's reference point 4. I have 3 more reference points, that's why it's starting from 4 now. So this is my reference point 5, and the load area is my reference point 6. So you can switch between the views and select at your comfort. So I have 4 reference points there. Now to couple these points, go to either create constraint points or go to the manager. So I have this already created. Let's create a new constraint. Constraint 6, tie constraint. We do not want tie constraint. We want to couple the area to a point only. So now it's asking select the control points to control points. So I want to select uh, reference point 4. You don't need to save it as a set. So let's select, and then it's asking for select the constant is on type. So I want to select the surface, press the shift button, click on this surface and this surface. So we want to couple this surface to the reference point. Okay. If you want to create a surface, you can give it a name. If not, then it's okay. So now it's asking how you want to couple this together. We want a constant degrees of freedom and kinematic. So we don't change anything. It will constant all 6 degrees of freedom to that single point. Okay. So you can see it has constraint already. We want to do the same thing here. Let's create another one. You can give it a name, say right support, um, or you can leave it as it is. So come on. Coupling. It's asking for the reference point. So we select this. When it's selected, it becomes red, and we don't need to create a set. And now we need to select the surface. This one, press shift key, hold it, and then select this one. Then it's done. We do the same thing here. We also do same apply same coupling on the top surface too, where we will apply the load. Let's create another one, load area, basically. So create on reference point 6, done, then select this surface, and then shift button, hold it, create. Okay, now you can go to the load option, and you need to apply support uh, with boundary condition. So what we'll do is we'll go to apply boundary condition, create a boundary condition, say boundary condition 5. You can either select displacement, rotation, or symmetry. So if your beam is simply supported, say, let's use the displacement rotation. We want to control the displacement and rotation. So it's now asking select regions for the boundary condition. So I want to select the reference point 4 only. And you can see it will apply whatever I am applying here, it will apply on this point. In terms, it will apply on this area. So we can restrain the U1 is the longitudinal direction, in X direction, U2 is the Y directional translation, U3 is the Z directional translation. So if you want to apply a simply supported beam, you can use either U2 and U1, then leave the other so that the beam can rotate. If you rotate this also, it will be a fixed beam, okay? So for simply supported beam, if the left support is a hinge, that means it cannot move vertically upward and downward, and it cannot move horizontally rightward or leftward. So we are restraining horizontal and vertical movement there. So it's a hinge support. Now let's apply a roller support at the right part. Let's create another another boundary condition. So you can select, you can give it a name at your convenience, say right support or roller support, whatever. So you select that reference point, and you can just apply vertical displacement constraint. So we are restraining it to deform vertical, like translate vertically. It should not go upward or downward, but it can rotate as well as it can translate in Z direction and in X direction. So that's simply supported beam. Then this is a roller, that's a hinge or pin. Now we want to apply the displacement control load at the top points. So what we do is in real test, most of the time we apply displacement control loading. We don't apply load, rather we apply displacements on beam from the actuator. So you go to, again, the boundary condition option, create boundary condition. We want to apply displacement and say load, apply load or load. You can give it a name as you wish, and then select that reference point, done. Now it's asking which way you want to apply. So, oops, sorry. Oh, so I think we have made a mistake. We need to create a boundary condition in the step 1 module, because the boundary conditions are, so the support reactions are created in initial step. So that's why, but the displacement is applied at the step after we apply the support reaction, right? So that's why it was not showing this box. So you need to apply the top displacement in step 1, not in the initial step. You can see the difference here. In initial step, we create all the boundary conditions, that means the support reaction. But when you apply the load, it will be created in step 1, not from the initial step. And also see the initially created support conditions are propagated in step 1. But when you apply the load, top displacement or apply load, it should be created in step 1. We have created on step 1 already. So now you can apply only in vertical direction. Say we want to apply negative 50 millimeter displacement. And also you need to see negative is vertically downward, where y is positive upward. So if you want to deflect the beam uh, vertically downward, you need to apply a negative displacement, okay? And that's in millimeter again. And you also need to apply how are you going to select this, how are you going to apply this load? That means you can create a function, create amplitude, and I have created that one. So I am going to use the amplitude one, and I should select OK. So you can see this one has been created, and we can come here. And how to create an amplitude? You can come to the model tree here and create on this amplitude option, create. It will have this window open. How you use tabular, you can just copy the time and frequency. So for example, the 50 millimeter load, 50 millimeter displacement, how we want to apply. So we can give it a ramp loading or a sinusoidal loading, or a different rate at different time increment. So the one I use is a tabular form, and you can see here I have divided the whole amplitude into 100 parts, and I applied it in 100 second, for example. So you can create a 0.001 in an Excel file and just copy it here. Some people just do it like 00, then at 1 second, the amplitude is 1. That's doable too, but for explicit dynamic analysis, sometimes it's better to use more fragmentative application. So I think you can do that too. So this is how we can apply the support reaction and load. You can see the support reactions and the loads are there. See the support reaction here. It means you have applied the support there, not support reaction, but you have applied displacement loading here, and it's shown there. So I think I'll stop it here. Next time we'll see something else.